Alright, welcome back. Today we're going to be talking about Unit 0, Lesson 3, which is the distance formula. The distance formula is used to find the distance between 2 points on a coordinate plane. So if we were looking at a coordinate plane here, and this might take me a second to get a coordinate plane up. Okay, so here we go. So I want to find the distance between 2 points. I'm going to show you two different ways. One is using what's called the distance formula, which is what this lesson is about. Almost nobody likes using it. And the other one is using our good old friend Pythagoras. So let's take a look at using the distance formula here. So let's give our two coordinates. Let's say our two coordinates are -2, 1 and 3, 4. Notice says hi again. So -2, 1 is right here. And let me actually use a different color so that that shows up nicely. -2, 1 is there, and then 3, 4 is here. And I want to find out the straight line distance between the two. So imagine that they're two coordinates on a map. You could even do this with longitude and latitude. In fact, that's going to be part of your assignment. But the distance formula. So the formula to do this is distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all inside the square root. Now this works if you have two coordinates. One coordinate is x1, y1, and it doesn't matter which one you consider to be that one. And the other coordinate is x2, y2. All right, so let's first, step number one, let's decide what goes where. So we're going to plug in values. So I'm going to say that -2 is x1, and if this is x1, then 1 has to be y1. And I'm going to say that 3 is x2, and if 3 is x2, then 4 has to be y2. So if I'm going to plug values into the formula, that means the distance between these 2 points is the square root of, in parentheses, 3 minus -2 quantity squared plus 4 minus 1 quantity squared. Now I'm going to evaluate. So that means that 3 minus -2 is 5 squared. 4 minus 1 is 3 squared. So the distance is going to be equal to the square root of 25 plus 9. So the distance is equal to the square root of 34. Now, for this example, I'm going to say that you need to have an exact answer. If it were something like distance in the real world, then of course you could use an approximation. But if we have to have an exact answer, the square root of 34, let's see, I can break that down into 2 times 17, and they're both prime, which means nothing goes outside the house, which means it just stays the square root of 34. All right, now that's one way to do it. Let's take a look at a completely different way to do it, not using the formula. Some people are going to like the formula, which happens, and there's absolutely nothing wrong with it, but this is the way that I do it, and I'm usually able to do it in my head. So You guys can give this a try. So what you want to do if you're using the Pythagorean theorem is way number one. Way number two is using Pythagoras. It's hard to say. Pythagoras. Yeah. To do this, the first thing you want to do is make yourself a right triangle, because the Pythagorean theorem only works on right triangles. So you need to make a new right triangle. Right triangle. So I've got my point here on my line up there. It's not great. Down here, not great. There's my right triangle. Now I want to find which one's the 90-degree side. So it's that one right there, which means I need to find out which one's the hypotenuse. If I draw a line straight out from here, the hypotenuse is the distance between these 2 points, which means that that's C. I need to find A and B, so I'm going to call this one A and this one B. It doesn't matter which is which. Now I want to find the lengths of these two sides, and the lengths of these sides is really easy to find because you can just count the boxes. So from -3, oh, I put this one in the wrong spot. This is supposed to be here. Oops. From -2 to +3 is a length of 5, and then from 1 to 4 is a length of 3. So if I put these in the Pythagorean theorem, step 2 would be find the lengths of the legs. Can't find the hypotenuse yet. Step 3 would be to use the theorem. When putting these into the theorem, it's a squared plus b squared equals c squared. So a in this case is 5 squared. B in this case is 3 squared equals c squared, which is the distance, what we're trying to find. 5 squared is 25. 3 squared is 9. 25 plus 9 is 34. So 34 is c squared, which means regular c is equal to the square root of 34. This is usually the way that most students find easier, but if you want to use the formula, there's absolutely nothing wrong with it. Let's take a look at another example with this. So do another page here, and I'm just going to choose 2 points at random. Let's go with, let's say 5, -4, and then let's say the other point is, I don't know, -3, -1. So you want to find the distance between these 2 points. Spoilers, the distance formula is really just the Pythagorean theorem. So I'm going to see if I can, or if I need to rewrite my numbers. Sweet, I can. All right. So I'm going to use the Pythagorean theorem, but it's really just the distance formula, just kind of set up in a different way. So I'm going to go 5 over, so here's 5, and then I'm going to go down 4, don't want to make a mistake again, 3 left, down 1. So here's my triangle. Now I'm going to draw on my line so that my line isn't super shaky. Draw on the other sides to my triangle here. I'm going to identify which side is which. So here's 90, which means the distance is the hypotenuse. I'm going to call this one on the left A and the one down below B, and now I can measure them. So the measure of A is 3 units, and the measure of B is 3 plus 5, which is 8. All right, so now I need to put it into the formula. The formula is a squared plus b squared equals c squared. Now a in this case is 3, so 3 squared. And b in this case is 8 squared. So 3 squared is 9, 8 squared is 64, 9 plus 64 is 73, and that's what c squared is. Now the square root of 73 then is what c is going to be. And again, you would need to pay attention to if you're being asked to find an exact answer or an approximate. For funsies, I'm going to say this one can be approximate, which means I actually need to break up my calculator. When you're told to do an approximate answer, make sure that you're going 2 decimal places. So the square root of 73 is, let's see, it's somewhere between 8 and 9, because the square root of 9 is 81, and the square root of 8 is 64. It's just me covering the time it takes for me to break up my calculator. So square root of 73 is 8.54. All right. Cool. So there we go. That was Unit 0, Lesson 3, about the distance formula. Feel free to ask any questions in class if you have them. And yeah, I'll see you guys in the next lesson.